Hello and welcome to Algebra. In our last lesson we multiplied monomials. In this lesson we're going to factor those and use the GCF. So there's two methods we can use to find the GCF of 5x cubed, 25x squared, and 45x. First way is to simply list them and pull all the prime factors out. Now 5 is a prime number, so 5 times x times x times x, there are 3 of those. 25 would be 5 times 5, and then there are 2 x's. And then 45 breaks down into 5 times 9, which is 3 times 3. So it is 3 times 3 times 5 times x. And what we want to do is we're going to find, is there a set of at least one that isn't all three, that's common to all three. Now I see that there's an x in common with all of them. I also see that there is a 5 in common with all three. And you notice that, for example, in the middle one there is another x, and the top one there is another x, but there's not another x in the bottom. So that won't work. It has to be in common with all of them. There's a 3 with a 45x, but there's not a 3 with either one of the others. So this is it. You have 1, 5, and you have 1x. So the GCF, greatest common factor, is 5x. Now there's another way that you can do this, which is affectionately called the magic box. We're going to put 5x to the third, 25x squared, and 45x in some little box thing. Alright, now we want to look, is there anything that will divide into all three of these terms at the same time? Well, yes, there is. 5 divides into all of them. 5 divided by 5 is 1, 1x cubed. 25 divided by 5 is 5, x squared. 45 divided by 5 is 9, and bring down the x. Is there anything else that's in common with all three of them? Yes, there's an x. So divide it by x. X to the third divided by x to the first is x to the second. You just subtract those exponents. 5 divided by 1 is 5. X to the second divided by x to the first is x to the first. 9 divided by 1 is 1. We don't even need to put that. And x to the first divided by x to the first is 1. So 9 divided by 1 would be 9. X divided by x is 1. So just 9 times 1 is 9. So we go through, we divide through. Is there anything that x squared, 5x, and 9 have in common? Well, no, there's not. So we're going to multiply these two together. 5 times x is 5x. So that's your GCF. What's nice about the magic box method is that once we have the 5x, all of these multiply together to give you this. So for example, if this were 5x cubed plus 25x squared plus 45x, you could reduce this into 5x onto x squared plus 5x plus 9, which is really where we're going in a little while, in a few lessons. Okay, so factor the GCF out of that. 4x to the fifth minus 24x cubed plus 8x. Well, the first way is to take the prime factors. So we're going to list these out. 4x to the fifth, negative 24x to the third, and 8x. And we're going to break these down into their prime factors. Now I'm going to say that this is 2 times 2 and then 5 x's. This is negative 1 times 24 is 2 times 12, 2 times 6, 2 times 3. So there are 1, 2, 3 2's and a 3, and then there are 1, 2, 3 x's. Now the 8x, 2 times 4, 2 times 2, so there's 3 2's. We have 2 times 2 times 2 times x. And now we're going to circle any pairs that we see. So I see a 2, I see another 2, I see an X, and as you look carefully through the rest, there's nothing else that is in common. So we have 2 times 2 times X. That is the GCF. Now it said to factor. Well, we need to factor this out, which means that all of these leftovers we're going to put in parentheses. Now this is a positive. Notice there's no negative. There's a negative here. It's no negative in this term left, so this is positive. 1, 2, 3, 4. So positive x to the 4th. In this row we have the negative, so we're going to subtract. 2 times 3 is 6. X times x is x squared. And in this term we have just a 2 left, and it's a positive 2. So this is 2 times 2, which is 4x onto x to the 4th minus x squared plus 2. And that's the factored form. So you pull out those that you circled. Whatever's left over, you're going to put inside the parentheses, and that will factor it out. Now using the magic box method, 4x to the 5th, negative 24x cubed, 8x. What's in common? Well, I don't have to necessarily pull out a 2. I see that all of these are divisible by 4. So I'm going to start off with 4. 4 divided by 4 is 1. X to the 5th. Negative 24 divided by positive 4 is negative 6. X to the 3rd. 8 divided by 4 is 2x. Let's double check. Is there anything else that we'll pull out of these? Well, there's 5 x's here, 3 x's here, 1x. We see at least 1x. If this were a 2, then there'd be at least 2 x's. If this were a 3, there'd be at least 3 x's. Basically, you're going to factor out the smallest. Notice you all have x's here. Now, if you had 2 sets of x's and 1 y, and there's no x's here, there's nothing in common. But if they all have at least an x, then choose the smallest of those 3, which is x to the 1st. So x to the 5th, I really don't need to bring down the 1. It's not necessary. X to the 5th divided by x to the 1st is x to the 4th. Negative 6 divided by 1, of course, is negative 6. X to the 3rd divided by x to the 1st is x squared. 2 divided by 1 is 2. X divided by x is 1. And so we have 2 times 1, which is just 2. And now we notice, multiply these, 4x. X to the 4th minus minus 6x squared plus 2. And so you can come up with it either way. It just depends on which way you like better.